So I'm going to be working on this question as a bonus question to end the topic division of polynomials, and I'm going to be using the two methods because there's something special about this question. It's a polynomial of order 5 raised to power 5, and as you can see, raised to power 4 is missing, raised to power 2 is missing. So if you are to do this using the long division, you need to assume or you take the x raised to power 4 as 0. So I'm going to do both. So here I'm going to have x minus 2. I'm starting with the long division method. Then here I will have x raised to power 5. I will have plus 0 x raised to power 4, even though it's not in the question. And I'll have minus 3x raised to power 3. Then I will have plus 0x square, and I'll have plus x and plus 5. So it's going to be a long one, and as we did earlier, you do x, the first term here, x raised to power 5 divided by x, and that will give us x raised to power 4. X raised to power 4, then we multiply x by x minus 2 by x raised to power 4. That will give us x raised to power 5 minus 2x raised to power 4. Then we do our subtraction, and this gives us positive 2x raised to power 4. Then we'll continue again with the division. 2x raised to power 4 divided by x, that will give us plus 2x cube, and when we multiply DMS, when we multiply x minus 2 by 2x raised to power 3, we have plus 2x raised to power 4 minus 4x raised to power 3. And I'll have to drop minus 3 x raised to power 3. So I drop that, and I will subtract. When I subtract, this will give us plus 1 x, but I might not want to write it, x raised to power 3. Then I continue the division again. We can still divide. So x raised to power 3 divided by x will give us x square up here. So I have plus x square, and I multiply now. X minus 2 times x square will give us positive x raised to power 3 minus 2x square. So I subtract. When I subtract, before I subtract, I will need to drop this. This will be positive 0x square. though it will have no effect, and this will give us negative here will give us positive 2x square. Of course, you know, here will be 0, here will be 0, and here also will be 0, so I might not need to write that. Then I still continue the division because 2x square up here can divide x up here as the divisor. So 2x square down here divided by x will give us plus 2x. I'll write that up here, plus 2x. Then I multiply x minus 2 by 2x. I will have positive 2x minus 4x. Then I go again, I subtract, but I need to drop plus x from here. I need to drop this down, so plus x. So plus x, we have that. Then I subtract. When I subtract, of course, you know, here is 1 and minus times minus is plus, so here will be positive 5x, and I'll still continue the division because positive 5x is bigger than x, and that will give us positive 5. So then I multiply now. When I multiply x minus 2 by positive 5, I'll have positive 5x plus minus 10, minus 10, and I'll need to drop this positive 5 so that I can do the subtraction, and the subtraction will give us negative here as positive 10, so the subtraction will give us positive 15. It will give us positive 15 as our remainder. So the remainder here is positive 15, and if we use the remainder theorem, which is my best method because, as I said, is shorter, as we did in previous example, you take the divisor, which is here x minus 2, you equate it to 0. When you equate it to 0, then you have your x to be 2. Then you put the value of x, which is 2, into the function. So that will be 2 raised to power 5 minus 3 into 2 raised to power 3 plus 2 plus 5, and whatever I have is the remainder. So what I did is to put 2 into x raised to power 5 from the question up here, then put 2 here, then put 2 here. So when I do that, I have there to be 32. I have 2 raised to power 3 is 8. 8 times 3 is minus 24 here, and I have plus 2, I have plus 5. So when I do this, I have 8, 32 minus 24, 8, 8 plus 2, 10, 10 plus 5, I have it to be 15. So the remainder here also is 15. So remainder theorem, long division, whichever, it depends on the question given. In this question, we are given, we are asked, it depends on what is asked. We are asked to find the remainder, and it's best to use the remainder theorem. Perhaps you are asked to find the quotient. You need to follow the long division method because the remainder theorem doesn't give you the quotient.